Okay, thank you very much. So this is a paper, a presentation describing work that I started with Andrew Aitken. Andrew was then at the National Institute of Economic and Social Research, but he has now moved to the OECD. So anyway, that's the explanation of why someone from the OECD is apparently involved in this. So the aim of this exercise is to prepare and to produce indicators for English lower tier local authorities of well-being. Now, the ONS publishes what it describes as a well-being dashboard, and there is at times quite a lively debate on how useful a dashboard of 43 items actually is. And my guess is that different people use different data items in the dashboard, but if you want to draw overall inferences from it, it's not at all clear what you should actually do. So what I'm describing here is an attempt to produce an indicator of well-being which is based on the structure of a utility function which values private household consumption and public consumption, which values life expectancy. The inspiration of that was the paper by Jones and Klenoff in the American Economic Review in 2016, but as an extension from that, we have also taken account of health status. There is quite a lot of discussion at the moment about how healthy life expectancy is much higher in some parts of the country than in other parts of the country. That undoubtedly is true, but if you focus on healthy life expectancy, you're implicitly saying that life spent in poor health, or the part of your life spent in relatively poor health, isn't really worth having. So we've wanted to move on from that a bit. We have calibrated the function using an estimate of the value of a road death averted, and that is a fairly common way of measuring how much life and life years are valued. And we compare each local score with the average for England. This is done only on England because of data availability. It might be possible to extend it to Wales as well, but Scotland has a separate demographic statistics system with its own registrar general, and the Scots seem keen on, why the registration system was set up with a separate registrar for Scotland, I'm afraid isn't clear to me, but it does have the consequence that you can do things with Scottish data that you can't do with English data, and vice versa. So the starting point, the core of it, as I say, is an instantaneous utility function. The utility function is assumed to be logarithmic, and that implies, it's essentially a Cobb-Douglas utility function, that there's a unit elasticity of substitution between public and private consumption. Now, of course, you can argue that the elasticity of substitution between public and private consumption is something that you could estimate, but and how do we know in any case that the utility function is logarithmic? Well, we do have some evidence that the utility function is logarithmic. Both Angus Deaton and Richard Layard, in studies of the connection between GDP and well-being, self-reported well-being, have suggested that the utility function is approximately logarithmic, or shows perhaps slightly higher curvature than a logarithmic utility function, but the evidence, such as it is, suggests that that isn't a dreadful assumption to make. And I suppose also what I have in my mind is that setting up something which has a declining marginal utility of consumption is actually a lot more plausible than simply looking at income and consumption aggregates, which would implicitly be assuming that the utility function were linear. So this may not be ideal, but it's simple to work, and it, I hope, is not too far from the truth. In addition to the consumption terms, we have got a term in leisure up here, and that again is fairly standard. The other thing I will mention is that we've got or two other things I'll mention. First is that we've got a constant in the utility function, and this is actually quite important, because if consumption is fairly low, then utility could be negative. If utility is negative, well, whether utility is negative or not depends on how low consumption is to the constant term in the utility function. If utility is low enough, then that at least takes me to the world of the Victorian novelist who wrote about people for whom life wasn't worth living. That is going to depend on the estimated value of U bar, or the other way around. If we have a value of U bar by calibrating the utility function, we can produce an estimate of the level of private consumption at which life becomes not worth living. Now, of course, this is just an instantaneous utility function, and if you had life not worth living at the moment but thought that things were going to improve, then that would be different from a situation where you saw no prospect of your circumstances improving. Then the other variable I'd mention is HT. This is the health status, and the structure we have assumed is that this is simply a dichotomous variable. For people who describe their health as good, very good, or excellent, it takes a value of 1. If they describe their health as fair, poor, or very poor, it takes a value below 1, and I'll come on to how we establish what the value below 1 actually is. So this is utility at any point in time. We can extend that to produce a value for lifetime utility in the manner expressed in equation 2. And here beta is the discount factor, the extent to which people discount future utility, and rho is the probability of surviving to period t for someone who starts their life, or we've looked at adult life only, from age 20, the probability of surviving to period t from the start of adult life. So the idea is that the longer you live, the more lifetime utility you get, and of course, if you spend that time in good health rather than poor health, the more lifetime utility you get from that as well. Now, of course, there's a question how you relate the lifetime utility to what you observe. We take a cross-section view of private and public consumption. We assume that there's no discounting, but equally there's no economic growth. So that your growth may change, your consumption may change with your age, but the discount rate is 0, and the underlying growth rate is per capita is also 0. You might think that's a rather gloomy view of the world, but it does actually make the calculations much more straightforward. Then we need to take account of the different survival rates of men and women. There are typically 2 approaches to working out life expectancy. The traditional approach is to assume that the observed mortality rates of the different age groups persist into the future. So-called, they used to be called interim life, they're now called period life tables that you produce from that. The alternative approach is to forecast survival rates, for a 50-year-old, what's the current survival rate when he or she gets to 80? And we used to think that would be higher than the current survival rate of 80-year-olds. People make nasty comments about economic forecasting, but the variables I'm very glad never to have professionally had any reason to forecast the mortality rates of different age groups, because the experience is that, or the experience of the last 40 years has been that actuaries first of all assumed that mortality rates couldn't go on falling. They did go on falling. So since about 2010, they've been assuming that mortality rates will start falling again, whereas in fact, even before COVID, the rate of decline had much eased off, or they had started to rise for some parts of the population. So the assumption of constant survival rates is a simple assumption, and if you like, the measure of well-being tells me what the lifetime experience of someone would be if the future would be like the present. We know it's not going to be like the present, but we don't know how it's going to differ. Private consumption, of course, we have to measure on a household basis. Jones and Klemoff talked about the consumption of children, and I must say I have absolutely no idea how they found data on the consumption of children. What I've done is to take the consumption of households, set the age of the household, the notional age of consumption by the age of the household reference person, and adjusted for household size on the standard, using the standard OECD equivalent consumption, equivalent size basis. So with those assumptions, as I say, discount factor of 1 and no per capita growth, we can evaluate, with assumptions about the parameters listed, we can evaluate life cycle welfare. What I have also done is to fit models which make the assumption that the age effects are the same throughout the country. Now, you might say that's not terribly plausible. Perhaps it's not terribly plausible, but we certainly don't have enough data to estimate models of consumption by age and location, where the age effects vary by location. At least I think it would need Isabel's magic to make that remotely possible. But anyway, what I've done is assume that consumption and leisure age effects are the same in all local areas. By leisure age effects, I mean the amount of time that people spend not working. We have treated people who are unemployed as though they work, because there is disutility attached to being unemployment, which is arguably at least as bad as the disutility attached with going out to work. Then what we do is calculate the variance in private consumption in each area needed to align welfare in that area with the population weighted average for England. We have 315 local authorities. If I say 315, someone might say it should actually be 321 or something like that. It does change slightly. For example, the city of Northampton went bankrupt, and in 2017 or something, the whole of Northamptonshire was merged into a single local authority. So you get slight changes in the boundaries. There are also changes in the boundaries in Suffolk and in Dorset. And one of the things I've learned is that if you have local authority data of slightly different vintages, they may be to slightly different geographies, which I've handled as best I can, but it's not, what I wasn't able to do was get a snapshot of everything on exactly the same local area authority, or perhaps I could have done that if I'd known it was an issue at the start of the work. So we have separate utility functions for women and for men. Here, LF is the number of life years that a woman spends, the number of life years that a woman expects to spend in a particular period. So the intervals in the data set are 5 years long. the mortality tables are at 5-year intervals, not at annual intervals, because obviously in local authorities you don't have nearly as many observations as you do if you want to work out mortality rates for the country as a whole. From those life tables, you can work out how many years a 20-year-old can expect to spend in each age group. We've got the utility term, the constant. We've got the private consumption. Here I have rolled up the logarithm of public consumption into the constant term. Why have I done that? You might say, doesn't ETB tell us how much consumption of public goods people of different ages and in different areas actually do, and why haven't I used that? Well, the answer is that, and I could know that it's not clear how far those consumption measures identified in ETB the effects of taxes and benefits study actually relate to utility. And in particular, if you think of spending on health, we know that spending on health is heavily loaded to old people. Those old people who are getting all this large spending would rather have the same be in the same circumstances as they were 30 or 40 years ago and not need the extra health spending. So if you want a measure of well-being, it perhaps is better to assume that the money spent on, say, health is used to raise the population, all the population to the same level to offset disutilities rather than to deliver utilities. Well, that's health. What about the other sorts of public spending? The one you can identify by age is education. And of course, education is a bit of a difficult one because education doesn't actually deliver immediate utility. Arguably, it's a form of investment. So you might say, I should have taken public sector education out of the picture. That is something perhaps to worry about in the future. But anyway, for each local authority, I weight them together by adult population weights to get the measure of well-being for England as a whole. And then I can say, how does consumption in England as a whole have to change to align it with the measure of well-being with the measure of well-being that I get in any individual local authority? And from that, I'm identifying the change in private consumption needed to compensate for differential survival and health effects, as well as differences in consumption. I mean, we can observe from the Living Costs and Food Survey that consumption is different in different local authorities, but so too are survival rates, and so too are health status. So this brings it all together. And if you want a measure of relative well-being to compare each local authority relative to England as a whole, that is a measure which does that and brings together work activity, survival, health status, and consumption all into one indicator. There are 4 main sources of data: the Living Costs and Food Survey, which gave just over 4,000 usable households in England, the Annual Population Survey, which seems to me a relative of the Labour Force Survey, that had about 80,000 men and 90,000 women that I think I was able to use. Then there are life expectancies by age and sex for each local authority in England. These are published on a regular basis. So I should have identified a 5th source of data. From the Annual Population Survey, the ONS produced measures of healthy life expectancy and thus health state on a slightly coarser classification than the LTLA classification. They produce it for upper tier local authorities, which are aggregations of some lower tier local authorities. And I've simply assumed that everyone in a particular upper tier local authority has the same health status. So some of the upper tier local authorities are the same as lower tier local authorities. for example, the big metropolitan boroughs or the London boroughs are, others may be aggregates, but I've assumed the same thing applies everywhere. Then we were given for each LTLA a number of covariates: the log of average electricity consumption, log of average house price, and the log of average income, with log of average income being taken from administrative data. Or rather, what we got, what's published, are decile points for equivalent income taken from these administrative sources, and this is a data set that was provided for 2015 to 16, but I don't think has been made available since. So with the covariates for each LTLA, we can fit a small area model to try and explain consumption and to explain work activity or disutility derived from work, and we can then take the fitted values and use those to generate the levels of consumption that we use in producing the measures of well-being. So what about the parameter values? Well, private consumption is about 74% of total consumption, but if you take account of the economies of scale in consumption, then it rises to 77%, essentially because it's not true that two people can live as cheaply as one, but we look at equivalent consumption, and that raises consumption per effective household member. Two people count as 1.7 heads if you want to work out per capita consumption. Because of the economies of scale in consumption, those are assumed not to apply to public consumption. So 0.77 for alpha. For the labour terms, we consider the static optimization problem, allocating their time between paid work, domestic activities, in the light of the wage rates and so on, and we set the epsilon, the Frisch elasticity, equal to 1. That gives a value of theta of 2.49. Now Jones and Clement have a much higher value in their paper, 14.2. I did write and ask both of them if I could see the calculations to make sure that I was doing them correctly, and I got a reply, I think, from Jones saying that Clement had done this, but Clement didn't send a reply. So, I mean, I do wonder whether I have confused weeks and months or something like that to get the 2.49. What I would say is that I did work out the results with their figures as well, and the correlation between that data set and my primary data set was 0.993. What we found was that the health status variable should be set at 0.75. That aligned figures for expected quality adjusted life years to a study which used quite different sources to explore the effects of ill health. We found that a prevented fatality on the road at 2016 prices was valued at 1.83 million, and if you assume that that was a person aged 40 years old, it values a life year at about £46,000, a figure appreciably lower than in the United States. That gives us a value of U bar of -8.7, and that in turn implies that consumption needs to be above about £5,000 a year for life to be worth living. I'm not saying that's a definitive answer. Perhaps it's at the low end of what I might have thought of as plausible, but it's not a ridiculous number either, at least I don't think so. This is the mixed model we estimated with the fixed effects for mean of log net income. These were the administrative data, log of mean electricity use and log of mean house price by MSOA. We had random effects for region, of which there are, I think, 9. Well, there are either 9 or is it either 10 or 11 in England, depending which measure you use. But anyway, that's a broad classification. Then we had age effects, and then we had local authority random effects. So we did, in fitting the small area data, estimate the value of the random effects for those local authorities for which there were observations. For the local authorities for which there were, thank you, 5 minutes, for which there were no observations, we just assumed that the random effects took their expected value, which is of course 0. This chart shows the equivalent income, or perhaps I should call it the equivalent consumption, for the top and bottom 10 local authorities in England. And you can see that the worst performing local authority was Stoke-on-Trent. That perhaps isn't a great surprise. Similarly, Middlesbrough, Blackpool and Oldham, well, I'm not terribly surprised to see there. I was a bit more surprised to see the beautiful city of Newcastle on Tyne there, but my guess is that although Grey Street does look rather wonderful, actually, though Newcastle has a sort of penumbra which is very deprived. Then the top performing, well, they tend to be sort of home counties rather than London boroughs. Richmond is the only London borough that gets into the top 10. Otherwise, South Bucks, South Oxfordshire, Surrey Heath, Chiltern, Windsor and Maidenhead, Tandridge, I'm afraid I'm not sure where Tandridge is, and then Hart and Epsom. Well, Hart is in, I was going to say Surrey, but it's a bit further to the southwest than that. Epsom and Weale is, of course, in Surrey. So these are in the prosperous belt to the west and southwest of London. And you can see we've put confidence intervals around them. The blue figures show the adjustment with the adjustment for health. The mauve figures show no adjustment for health. And you can see that it actually makes very little difference which figure you look at. Yes? Yes. Yes, for log consumption and also for the leisure times.
And then you are estimating average income.
I'm estimating aggregate consumption in each local authority.
I'm asking, are you using eBLUP or are you using EBI?
I'm using eBLUP, I think. I think so.
It's not good for transformations.
It's not good for transfer.
No, when you do apply transformation, then your target parameter becomes non-linear and you need to apply EB.
Well, I estimated the model on the log of consumption and with the log of income. So, well, I will have to consult you on that. Thank you very much. Okay, well, there were bound to be questions from anyway. This chart shows the equivalent consumption plotted, the equivalent consumption measure plotted against the life expectancy adjusted for health. And you can see perhaps, which isn't a surprise, that they both have an upward drift. These are the rankings of the local authorities. Then the government already publishes indices of multiple deprivation, which are produced from a range of variables and circumstances. They construct those at MSOA level, of which there are 6,000 in England, but they also aggregate them to LTLA level. And here what I've done is plot the ranking of the IMD measure against the ranking of the welfare indicator. And you can see that there's a general upward drift, but in particular, there are some London boroughs that are outliers. So, it's not pointing. Westminster up here is ranked 300 on the welfare indicator, one of the best performing boroughs, but it's ranked only about 100, 110 in the indices of multiple deprivation. And though the indices of multiple deprivation are intended to reflect pockets of deprivation, But I suppose all I can think is that actually there must be a very high implicit degree of inequality aversion in the indices of multiple deprivation, because if we look at Westminster, for example, it has the 4th highest life expectancy of a local authority in the country. I think the similar issues probably arise with Hammersmith, Kensington and Chelsea, and Wandsworth up here, and Camden and Barnet. So anyway, this is obviously a different way of looking at well-being from the indices of multiple deprivation, but it does raise an issue in my mind whether the indices of multiple deprivation are implausibly inequality averse. I think that's perhaps something that it would be interesting to look into. Here, what I've done is to show the correlations. This is the measure of well-being. This is with the geometric mean of income in each authority, with the first decile of income, the indicator of multiple deprivation, the income component of that, the employment component of that. Anyway, this shows how the various data points are related, and the income component of the indicator of multiple deprivation is actually not income, it's the proportion of people claiming benefits, I think. Sorry, let me just, well, perhaps I should stop here by saying what I want to do in the future. The next piece of work I have in mind is to extend this to take advantage of local environment, to take account of local environmental effects. If you can explain the effects of, if you can identify the effects of the local environment on self-reported well-being, and you can also identify income effects, you can establish prices for things like nitrogen dioxide concentration, distance from main road, and distance from green space. So to sum up, this offers a means of bringing together a range of issues into a single framework that would provide a single indicator of well-being at a local authority level. Thank you very much.
No, I mean, what you want to estimate is very complex. It requires modeling of different variables. Actually, in a small area, I would say I have not seen any paper on estimation of on a small area estimation of parameters that depend on variables of different nature. You can say so you could use like a separate modeling for it, but they might be also dependent, like consumption and.
Yes, I have assumed that consumption and work are independent. I mean, that's a very reasonable criticism.
Yeah, so that's the automatic way, I would say, the only way I would, but I have seen, but so it would be much more complex to consider dependency.
Well, yes, it would be three-stage least squares done in a highly, well, I don't think you can do mixed estimation of multiple equation. I've never seen.
It's a hard problem, I would say. I have not seen any paper on that.
No, I think I can see why.
Okay.
Helen.
Before you actually did it, I was going to suggest correlating it with the index of multiple deprivation. And it just seems to me that they're probably measuring different things, and the questions on the IMD are all framed around negative things like proportion of people on benefits, as opposed to yours is income, which in somewhere like Westminster or Hampden, you're going to have enormous heterogeneity among the population there, and the IMD is picking up answers from the poorer population, and maybe yours is picking up answers, well, not answers, but an average based on some very rich people. I'm not sure. There must be something.
I mean, there's an element of that, but that was why I referred to life expectancy, because a few very rich people aren't going to deliver a very high life expectancy if there aren't very many of them.
I suspect there's probably a lot of both in those London boroughs. Maybe each IMD is going to up something quite different to what.
Well, I mean, this
it's
is
a mystery, but and also understanding the weights, how they weight those things together in the index of multiple deprivation.
Well, I agree with you, but I mean, that was what I tried to wrap up in the question. What is the degree of inequality aversion built into the indicator of multiple deprivation?
Agreed, the way that what they're measuring and what they're, by which you mean what they've chosen to measure.
Yes. Yeah. What would it look like
and
if
how they weight together.
Yes, what would it look like if we translated it into the language that Tony Atkinson gave us?
How did you treat housing services? Did you, for owner occupiers, if you rent them?
No, what I did was dirtier than that. All I did was we had consumption figures provided by the ONS, essentially the living costs and food survey. The consumption figures were scaled up to the national aggregate on an 87 category basis. Now, quite what they did to adjust the housing side of that, I'm afraid I'm not sure. I still found that they didn't quite match the private consumption figures I had and scaled them again. So there's a scaling issue that sort of obscures that.
Yeah, so I have a question about the definition of well-being. It's obviously here you're divided according to the social activity function, which is consumption-based, leisure-based. But then in a more general sense, people think of well-being as a happiness. There is a lot of perhaps non-economic research to indicate richer people are not necessarily happier. Retired people who've got loads of time are not necessarily happier. People might care about sort of justice, or maybe inequality sort of comes into play. So, what, like in general, what do you think should be the definition of well-being?
Well, I suppose the truth is I don't think about that. I think I'm trying to think of questions that can practically be answered. I think whatever measure of well-being you come up with, it will be subject to criticism. People will be able to say either it's not giving enough weight to this or it's giving too much weight to this. But my sense is that, the alternative approach you can go down is the sort of route that Lord Layard recommends, where you look at self-reported well-being. And I think that does have some merit. But that said, what you typically observe on that is that the dial hardly moves. So if, for example, I were concerned about levelling up, then I suppose what I've described here would identify, I mean, maybe people know that anyway, would identify where the levelling up needs doing. And whereas if you looked at people's social concerns and so on, no, I don't think you would get that question answered. But anyway, that was a rather difficult question you asked, so I'm sorry I've ducked it.
When you started out with the dashboard and all of those things, that immediately in my mind I was thinking, well, why don't I want a composite indicator with some weights that allow me to stick all those things together? Will your model actually generate for you what those weights should be? Or am I being far too optimistic about that as a language strategy? Well,
of 43 items, it's giving 0 weight to quite a lot of them. But it is implicitly trying to combine a small number, to provide a framework for combining a small number of variables. I mean, the issue of whether weighting them is quite the right way of putting it because the system is non-linear, I'm not sure, but yes, that is implicitly what it is trying to do.
Thank you very much.
My co-author of this talk, James Cheshire, and I both work in something called the Consumer Data Research Centre, based at University College London. And to cut to the chase, really, thank you for staying for the last presentation. To cut to the chase, what our take on small area estimation in this presentation is that sort of ultimately geography is flawed by any aerial aggregation. And the spirit of what we're seeking to do in this talk is to front load many of our modelling assumptions right back to the individual, which is the only natural unit of analysis to understand human agency. And I should begin with a shout out to James's parents for naming him James, because it transpires that James is the only male name that's been in the top 20 male names since World War II. And so if you have had an infant named James, you've truly bequeathed the sort of gift, and it is a gift of anonymity, so if you were called Ralph, for example, you're on a much sharper cohort, last year official statistics reveal that there were 6 infants born Ralph, and so you're one of a rather small cohort, but I suppose even that's 6 more than were called Rolf. Here we go, if I can find the button. Yes, fools are still keeping their heels. My parents were slightly prescient. I'm before the peak. I'm before the peak here, and there's still about 500,000 of us around. And where that's relevant, is that it's an example of the ways in which we can imbue individuals with particular characteristics based on tokens of identity, or specifically a token of identity that is universal. And in the Consumer Data Research Centre, what we try and do is we try and access new sources of smart data, which allow us to build new models in many respects that allow us to break free of the scale-based generalization that's implicit in most all geographic analysis. And so this is really the structure of what I want to go through in this presentation. I want to say something first of all about not just how we infer age from names, but how we can infer other characteristics, and how that's of use in many applications, along with inference of gender, ethnicity, and characteristics of neighbourhoods. And where how we liberate that, how we actually make that happen, is using something that we call a series of linked consumer registers. And basically what we've tried to do in the Consumer Data Research Centre is get the names and addresses of every adult in Britain. And we've tried to do it for every year from 1997 through to the present day. And so if we've got this, we've got through names and addresses, we can get locations, we can geo-reference the individual locations to very high levels of precision. We can infer individual attributes, and we can devise representations of the world that are more granular in spatial terms, because we free ourselves from the aggregation issue, and in temporal terms, because we can update them as frequently as we can get refresh of names and addresses. So if you just go through, picking up what I just showed with the pool names, you go through the people who are on this stage of the the programme, you get very different age distributions for the names that have come up. And there are some of them, you know, sort of our tau gets a bit spiky. There are problems with names imported from abroad because we're assuming a UK basis to this particular generalisation. But these sorts of things can nevertheless be done to look at to develop equality audits, if you like, to sort of examine not only the age and gender distribution, for example, of payrolls, but also to look at ethnicity distribution. So a name is a statement not only of your age and your gender, but also your ethnicity. And again, in the Consumer Data Research Centre, we've harvested a global names database of about 1.2 billion individuals, so sort of 1 in 7 or so of the planet's population. And we can devise quite simple models that allow us to infer most probable country of birth or geographic origins of people based on weighted sums of their given and family names. And even that slightly underestimates what we do, because for certain hard to reach ethnic groups, we can invoke sort of twists and re-weightings that I would like to think that even AI cannot think of. So for example, in seeking to predict membership of the Black Caribbean ethnic group, we use the list from UCL of all of the individuals who received compensation in, I think it's the 1831 Abolition of Slavery Act, for their liberated slaves, many of which took the names of their bearers. And so that means there's a different probability of being Black Caribbean if your name is Cameron, for example, to if your name's Longley. There weren't many Longleys that had slaves, whereas I've actually met David Cameron in the house next door. He's a gas fitter for Centrica, and it's of Black Caribbean extraction. So these are the sorts of things that. Whoops, Daisy. Sarah, you might have to help me. Is it that one?
Next one.
Oh.
Would be helpful to use the clicker.
Clickers, yeah.
All right, let's try that. It's going to be left until someone spots us.
Use it.
Yes, yes.
Sort of clumsy.
We're going to have to look at that for a long time. Oh, there you go.
Okay.
Right. Okay. Yeah. So the issue of validation of this, though, sort of is absolutely crucial. And so these are our overall results in our sort of predictive model of ethnicity for the UK, Great Britain, sorry, in 2011. And what we do, these overall figures mask under prediction and over prediction. So what we do is we map them right down to fine levels of granularity and compare them with the census, 2011 census in this case. And again, here we use a number of sort of clever tricks. So the white Irish is actually a very difficult group to predict, because you're talking about self-identification with being Irish. And the way that we actually build this particular part of the model is looking at the proportion of people with Irish family names that in the 1851 census said they were born in the island of Ireland, for example. So there's lots of sort of specific tricks that we can use to bring I'm having trouble with that. It's all right. I'll try again. Yeah. So there's lots of tricks that we can bring to this, and if we can do this, sort of successfully, and we believe we can, and the results are ultimately in the seeing. You can bring greater temporal granularity to estimates, because rather than waiting for a 10-yearly census, you can get an estimate of the spread of the change in the distribution of an ethnic group with annual refresh. So here we're looking at the diffusion of Bangladeshi group outside the sort of Spitalfields area of East London, with annual updates. And you also get greater granularity. The white other group subsumes many different sort of ethnicities. And so you can look within look many different nationalities and groups. And so you can actually model the distribution of people that are likely to identify as Polish in the country, rather than lumping them in with French, Lithuanians, or whatever in the white other category. This is one for Lars. I think Lars is moving about here. I think Ashley Road's about here. You can also, through these registers, look through whether somebody's present from one year to the next. And so you can build representations of population churn, sort of with annual increments. And here again, sort of if my eldest daughter's actually just buying a house out here in Forties Head, and you can see there's a high turnover, apparent turnover rate there, which arises, sort of as becomes apparent when you reconcile these data sets with aerial photography and satellite imagery, which actually show that area of sort of suburban or ex-urban Bristol has had very considerable development in recent years. So that's what we can do just with sort of names in a cross-sectional sense and comparing them over time. The next thing that we can do is we can sort of try and build dynamic models of residential change, which are also scale-free in terms of the small area debate. So, although my ego would like to think there's only one Paul Longley, there's actually 8. And most names are not unique. Over time, more names are becoming unique as Britain becomes more multicultural, more multi-ethnic, and as lifestyles mean that fewer of us use the same names when we're naming our children. But this helps tremendously when we compare adjacent years and we're trying to build a residential mobility and migration model, because although there might be 8 Paul Longleys, it's unlikely that more than one will move in any year. You can also tag it to Paul Longley's partner and look at couples that actually move. The most common couple's name in Britain, I think there's about 5,000 John and Margaret Smiths. But even when you go to the most common one, you can get away with relatively few assumptions in terms of identifying moves. And this is the result sort of within London. You see very few, but most moves tend to be within London boroughs, and this isn't programmed because the data are not borough specific. These are point-based occurrences geocoded to Ordnance Survey address point. Most people tend to move within boroughs, and relatively few people move across the river, for example. So you get some idea of residential mobility patterns, again, in a scale-free manner. And again, we check these against mid-year population statistics and other government statistics. This is the ratio of in-moves and out-moves at district scale for selected years, comparing our results with ONS statistics. And the fit is pretty good. It's not perfect because we're not picking up everyone, but there's no systematic evidence that we're picking up a biased subset of individuals from this melange of data. So, what more can we do with this? Well, so we've got these individual linked models at the individual level. What we want to do is link them to other things that have been flagged up, sort of during this afternoon's presentations. Many of which are also available at the individual level, or the level of the individual property. So, for example, land registry house price sales are not deemed personal data. They're available at the individual property level. We were talking about energy performance certificates earlier. So there's no reason why you can't tag to Paul Longley's name and address. And these are all held, we should say, in ISO 27001 secure environments. So basically, you can't look at this outside of a very secure setting. And so you can link them at the individual level to properties to find out what's going on with changes following moves. And as we heard in the previous presentation and various others today, one of the obvious candidates is the index of multiple deprivation. One of the problems with the index of multiple deprivation is there's so many of them. They're not only sort of periodically updated and changed, but there's a different one for Scotland, Wales, Northern Ireland and England. And in the little example that I want to sort of set out here about how the IMD ultimately can give us a clear population-wide basis to understanding geographic and social mobility. What we've assumed is that the 75th percentile in Scotland's IMD is the same as the 75th percentile in England's IMD. Okay, so there is some sleight of hand there. That's the only way we can get a GB, indeed a UK-wide IMD index. But if we accept that, what we can do is begin to get some idea of the sort of social, the way that social mobility accompanies spatial mobility. And so I think, yes, I think this is another example of looking at the IMD scores of people that move out of an area. And the IMD score of the place that they vacate, and the IMD scores that they go to. Okay, and so we can link at the individual level, the level of the household and the individual property, social mobility with spatial mobility, and so to some extent at least get round the ecological fallacies that characterize much such analysis. Moreover, of course, we not only know the origins and destinations of the individuals, but through the names we can model the ethnicity. And so when you overlay this, when you again we go back to the Spitalfields area, this is where people of Bangladeshi extraction are moving, and this is where people of white British sort of ethnicity are moving in using that escalator housing market, if you like, as a way of pushing forward housing careers. And we can, again, it's a scale-free representation of the world, and so or Britain, and so we can do it for any convenient scale. And so in terms of IMD, we can look at the consequences of residential mobility for any convenient population. Some other research applications of this, and I think we're doing all right for time. An obvious way that we can use these data to compare demographics of nighttime residents with demographics associated with activity patterns. And so this is now some fairly old stuff from Twitter. And what you can see on these age pyramids is the overall age pyramid revealed by the 2011 census. So each age pyramid shows the age pyramid associated with where people sleep. But what we can do, sort of from Twitter handles, is work out people's names and then work out their age profiles, sort of based on that. And so based on that, we can sort of work out the gender and age profile of the O2 Arena, the Emirates Stadium, Canary Wharf, and Westfield Stratford. For any time period, again, for which we've got data. And so these are based individual level estimates that allow us to break free of the shackle of nighttime residents as the way of looking at individual identity to characterize their overall activity patterns. Here's something I think is actually rather more sinister. Surnames in Britain came into common parlance, depending on the precise part of the country, at some point between the 12th and the 14th century. Okay. What we've done here is we've got our standardised IMD score from the very worst LSOA to the very best one. Okay, and so it's a range standardised index from 0 to 100. So what should be the average IMD score of someone called Smith? Well, your name's got nothing to do with where you live, of course, has it? Of course it hasn't. And so it's got to be 50. And sure enough, it is. And when we look at most common names, my eyes are terrible here. We've got Jones, Williams, Smith and Brown, bang on, for 50. Let's look at some other names, sort of, which we've got here, sort of starting off with Offer. And the IMD score isn't 50. It's significantly higher, which is bizarre. How can the name that your ancestors took 700 years ago determine the quality of neighbourhood in which you live now? And at the other end of the spectrum, we've got the McShanes, and they're very significantly adrift of the other way of that mean of 50, which is completely impossible. But then I go back to when I was talking about the ascription of the Irish. I sort of let slip that what we've done is we've geo-referenced not just all of our consumer registers from the last 25, 30 years, but we've also been able to geo-reference most of the individual records from the 1851 census. Okay, and so what we can do is we can look at where the McPhees and the Offers, for example, lived in 1851, and we can draw something called a kernel density estimate around it. So we can draw an enclosing envelope that encloses 75%, 80%, 90%, you name it. We can draw an envelope that encloses most of the bearers of those names. And here's an illustration of that. And so this is where 75% of the Offers lived in 1851. And this is where 75% of the McPhees lived in 1851. And so there's a very strong geography. There's a very strong geography to where they came from. And this actually sort of, you know, it pushes us to actually sort of think about the intergenerational consequences of residential mobility. Because although, you know, I'm not getting into my cliche mode here, as academics, we always focus on people who move. Most people don't move. Most people stay where they are, where they were born, and they remain there throughout the generations. So here's a thought experiment. Take the average deprivation score for an offer or a McPhee today, but based on our sort of point in polygon analysis. But don't just do it for McPhee and an offer. Do it for everyone. Do it for every white British name that is long established in Britain. Okay, and so you've done that previous graph, not just for half a dozen names. You've done it for all the names that were present in the 1851 census. And then let's go back and say, okay, what we're going to do is we're going to ascribe the present day IMD score to the great-great-great-grandparents of residents today. And so you're actually getting an idea, you're getting a measure of the deprivation score that those living in 1851 are going to bequeath their great-great-great-grandchildren living today. And that's the result you get. So you get, you know, a very classic north-south divide and an east-west divide, in actual fact, you know, sort of in Scotland, which gives some benchmark against which to calibrate intergenerational inequality. So that's a benchmark from the past. What about benchmark from today? I said we can do ethnicity. So what we've got here in these ridge plots is we've got the IMD scores of all the census, different census ethnic groups, the ethnic groups identified within the census as identified from their names. And what you can see them all jerking as the numbers change at the top. This is an indicator, this is a measure of the changing relative circumstances of the main census ethnic groups over the period 1997, I think, to 2016. There are reasons why we stopped at 2016, but we can cover on. And so you see the sort of, you know, the stability that characterises the place as a whole. White Hub is actually quite interesting. You see this one jerk when EU accession lets in less skilled individuals from former Eastern European states. So we can do that in terms of temporal frequency. So we can increase the temporal frequency of our estimates of deprivation. We can also increase the granularity, because I showed you the graph of the distribution of the Polish in London as opposed to the white other. And so we can actually sort of unpack the sort of, you know, the BAME acronym, if you like, to look at the deprivation circumstances within these census groups. And so we can look at within the sort of white other, the Asian and the Black African deprivation scores. And so what's really apparent from this, you know, don't forget the white British average is about here. The white British average is about here. And so more recent migrants live in much inferior circumstances, but, with some exceptions, but there's also quite considerable within group variability that's picked up between these things. Right, we can, having done this for individuals, we can do it, you know, we can work it out for households as well. So we worked out the age distribution for Peter. If Peter lives with Helen, based on sort of assumptions about how much younger Helen is likely to be than Peter, typically 2 years, we can work out, you know, sort of that joint most probable age. And that enables us to do the other aspect of, you know, sort of small area validation, if you like. That our register, as I said, we try and get everyone's name and address, and we're only sort of partially successful in that. What we can do is use a methodology called the iterative proportional fitting, the workhorse of a technique called micro-simulation, to fill out the missing gaps in our register. So if, for example, we know from small area census statistics, we're missing 5 females, 7 males, these numbers of ethnic minorities, these numbers of age groups, we can use iterative proportional fitting to identify, you know, sort of the most probable probable combinations, and then stick them in the missing bits of the missing geo-references that we've got in our data set. And the sort of way that we do these, okay, we're good. And so the sorts of things that we do, okay, you can see here on Recovery Street, we've got one person missing in the flatted house on the left-hand side. Well, we might, in terms of ethnicity, put them in with the same ethnicity. The next flat that we've got one of the 3 missing, second from the right, we've got a tied, you know, sort of ethnicity, but we know the ethnicity of the people living next door, so that becomes determinant. And then based on that, okay, we've got no one from the flatted property in the middle. Well, we use the neighbour rule. Birds of a feather flock together, you know, the sort of first rule of geodemographics. And that would be one scenario about how we would do that sort of thing. So these are I suppose these are the conclusions that come from this. I mean, basically, pushing back these assumptions that we make about individuals and basic demographic characteristics can provide us with data that are distribution free in a geographic sense, and which can be used to underpin quite sophisticated analysis. However, consumer data by definition are incomplete, and the stuff that we've described here is sensitive. It's actual or modelled personal and sensitive personal data that has to be kept in ISO 27001 environments. And those data sources are incomplete, and so we need to fully understand the source and operation of bias with respect to external data sources. But if we can do that, geographical analysis becomes free from the shackle of aerial aggregations, and we can develop point-based analysis, point pattern analysis, where before we were shackled to administrative objects, which, you know, sort of may be of analytical convenience or administrative convenience, but may not reflect the within-zone heterogeneity that's observed within those units. And then the final thing is really, you know, sort of in the very particular context of social mobility studies, and that's to say that, you know, the introduction of the family group as an aggregation, as a unit of analysis, provides another way of understanding both continuity and change in urban and regional systems at a range of geographic scales. So that's it. Thanks, Lars.
Thanks for this really interesting So I must have missed it from the beginning, but can you describe again where the data come from, what's the coverage, and what are the chances of people access?
Right. So yeah, so the data come basically we get the data from wherever we can get it. Okay, and so a staple of the data set is the public version of the electoral register. Okay, what we've done in the past is we've also sort of harvested various consumer data sources where people give appropriate consents for their data to be used for research and very often other purposes such as marketing. So we've got a data partner, for example, called PDV based in Watford, and they've got a rolling panel survey. Sort of, I don't know, they send people coupons for this, that, and the other, and people consent to the use of their data for that reason. Other things are a bit more ad hoc. Sort of basically, if you filled out a guarantee card for your kettle, the new kettle you bought, I don't know, sort of 8 years ago, and didn't opt out or whatever, we've probably got that somewhere. And what we also do, the issue of linkage, which I described, we'll also use sort of carry forward. So if you've disappeared from the electoral register, but we know your house is owner occupied and it hasn't been sold, we'll leave you there until the land registry tells us the property's been sold. Or if we know it's rented, we get data from Zoopla, one of the one of the letting consolidators. And so when stuff is re-let. When people use Royal Mail redirection services, sort of, for example. And so you use those sorts of things as triggers. The second part of your question, the data held in a non-disclosed location within UCL. What we do in the Consumer Data Research Centre is we make research-ready versions of it available as part of the data service. We don't, as a rule, let people in to actually look at the individual records because there's more than a dozen data licensing agreements that govern access to the data, and so we're allowed in the centre to access it, but not to, for obvious reasons, to let third parties look at it.
So what's the coverage? How many people?
Oh yeah, so for 2000, so if you go back right to 2011, worryingly, it's more than 100%. Okay, in many areas we've got more than 100% because sort of stuff. So you collect all this stuff in a dustbin, sort of, and for many areas you have more than 100%. If you get back to 2023, we're down to about 54%, but that will go up over time. And the reason it will go up over time is when people move house, for example, they typically take, unless it's an election year, they typically take 2 years to register their new address, sort of, for example. Okay, and that's why, going back to my little ridge plots, we cut a lot of the stuff off. We can provide you an estimate, small area ethnicity estimates for Q2 2023. They will be estimates, and they will be more volatile because literally that's all that's come through now. The dust will settle, sort of over a period of 2 or 3 years.
So to answer this, if you want access to it, go to data.cgrc.
Everyone's whacked glass. I think it's time for the pub.
I think you are correct.
We're going to go around the corner with the college arms. Yeah, more to the right.
Where is it? Right. No, so you can get that up. Yeah. Right. House. Yes.